far beyond our galaxy, past the veil of everything we've ever seen. A whisper of light flickered from the darkness. It wasn't a star, nor a dying sun. It was something else. A quantum anomaly. A signal that shouldn't exist. Buried in the cold silence of the cosmic edge, it pulsed with a rhythm that defied time, matter, even physics itself. Scientists stared at their instruments in disbelief. What had they just discovered? A glitch in reality, or a message? And if it's a message, who or what is speaking from the end of the universe? Subscribe if you believe the cosmos still hides impossible truths. Join us as we unravel the quantum heartbeat echoing from the edge of existence, because this might just be the strangest signal humanity has ever received. The Atacama Desert in northern Chile is a place that looks more like Mars than Earth, dry, desolate, and whisper quiet. It's home to some of the most sensitive instruments humanity has ever built, a place where the night sky speaks in riddles, and sometimes, in revelations. In April of 2024, under skies so dark they reveal stars you can't name. Something changed at the Alma Observatory. Dr. Amina Rowe stood over a glowing monitor, half-drained coffee in hand, analyzing data from a deep sky scan aimed at a silent patch of cosmos. It was a region thought to be cosmically barren, a cold void beyond the Perseus-Pisces supercluster, 100 million light-years away. No stars, no gas, no life, nothing, and then a pulse. A sharp photonic signature flickered across their screen, not once, not twice, but in a rhythmic, almost intentional pattern. At first, the team thought it was a hardware glitch, a common enough occurrence in high-sensitivity instruments. But when the same signal echoed through not one, but 3 independent observatories across the globe, one in Hawaii, one in South Africa, and another in New Zealand, everything changed. This wasn't a mistake, it was real, and it was impossible. The pulse didn't behave like any known celestial signal. It wasn't the remnant of a supernova or the echo of a neutron star. It didn't match gamma bursts, fast radio waves, or gravitational waves. This light was sharp, unnaturally sharp, as if it chose its shape. More strangely, its quantum properties seemed to defy causality. The photons detected were ... entangled. That shouldn't happen on this scale. Entanglement, once thought to only exist in lab conditions, was now appearing in light that had traveled billions of years through space. Even more baffling, the photons arrived at different telescopes at slightly different times, but when the data was aligned, they mirrored each other perfectly, as if they were different instruments recording the same line of music from different speakers. Somehow, this signal knew how to stay quantum coherent across time and space. And that's not just weird, that's unprecedented. Dr. Rowe convened with her international colleagues via encrypted link. Words like non-locality, violation of Bell inequalities, and even quantum consciousness were nervously tossed around. But beneath the jargon, one truth was taking shape. This signal wasn't just strange. It was impossible under our current understanding of physics. The origin of the light, a narrow coordinate just past the edge of our deepest astronomical surveys, an uncharted void, colder than the cosmic microwave background where no known structure exists. A region so still it was previously ignored by cosmologists, dismissed as cosmic background noise. A place believed to be ... dead. And yet, from this graveyard of space, came something alive. What followed next could only be described as a scientific wildfire. Data packets zipped across secure networks, theories sparked across physics forums, and journalists began catching wind of the phrase being whispered in elite labs. Quantum light signature, QLS, a new term for a new kind of anomaly. A pulse of light that carries more than energy. A signal encoded not just in frequency, but in entanglement, like a message written in the very fabric of reality. Dr. Rowe, a quantum astrophysicist with a background in theoretical light transport, had seen strange before. She'd studied black hole photon spheres and early universe inflation models, but nothing in her career prepared her for this. In a late-night press call, she said, "We're not just detecting light. We're detecting intent. This signal behaves as if it wants to be found." Her words sent chills through the scientific world and sparked a storm online. Conspiracy forums lit up. Alien transmission, some said. Quentum. Aye. Others claimed it was a warning, a countdown, a code, but the signal didn't repeat. It just ... hung there, suspended in the data like a static whisper from across time. And yet, it continued to bend the rules. One team noted fluctuations in the signal that seemed to correspond to observer input, as if watching the light altered its phase pattern. But how? Was it a quantum trick, or something deeper? What if, somehow, this wasn't just light, but communication? And if it is a message, who or what sent it? A long-dead civilization echoing across the stars. A mirror of ourselves, scattered through spacetime. Or something that was never biological to begin with. We've long assumed the universe is quiet because no one else is speaking. But what if we've just been listening in the wrong dimension? What would you do if the first message from beyond wasn't a voice, but a pulse of impossible light? This is just the beginning. The world's top minds were already gathered virtually, secretly, trying to understand what they were looking at. Because the more they examined the quantum light signature, the more impossible it became. It didn't match anything. Known celestial phenomenon even came close. The team ran it through every catalogue: fast radio bursts, quasars, pulsars, magnetars. None of them had the entangled photonic fingerprint. None of them displayed quantum coherence across such massive distances. This wasn't just new. It felt like it came from outside our cosmic rulebook. Enter Dr. Luca Mendez, a soft-spoken but fiercely analytical astrophysicist at the European Southern Observatory. He had spent most of his career mapping redshift anomalies and gravitational lensing patterns, but he had a side obsession: outlier signals. He proposed a radical possibility. Maybe this isn't light, in the way we understand light. Light, as we know it, moves in straight lines. It bounces, it bends, it slows through glass and zips through vacuum. But it follows rules, rules that even black holes respect. But what if there are states of light we've never observed? Mendez suggested the signal might originate from what he called a quantum phase variant of light, a higher-order electromagnetic expression only visible when specific entanglement thresholds are reached. In simpler terms, this light wasn't just traveling through space, it was folding through it. To test his theory, he reached out to someone who could interrogate the signal in a different way. Dr. Sophia Liang, a leading expert in quantum optics and Fourier light mapping. Dr. Liang was known for her unorthodox work using AI to analyze lab-generated entangled photons and extract patterns invisible to the human eye. When she received the QLS dataset, she ran a phase decomposition through a quantum-enhanced Fourier transform. The result: a waveform that oscillated in more dimensions than three-dimensional space could hold. The signal had spikes that faded in and out of known frequency bands, as if part of it was disappearing and reappearing, not randomly, but rhythmically, consistently, intentionally. Dr. Liang's first reaction was laughter, not from amusement, but disbelief. It's like the signal is blinking into a dimension we can't perceive, ... And then, blinking back. Imagine a flashlight shining through a rippling sheet of water. To a flat observer, the light would seem to stutter, flicker, vanish, but in reality, it's moving through a different medium entirely. That's what this signal was doing. It was dancing between dimensions, and that changed everything, because if light, the very fabric of visibility, could phase between unseen realms, then maybe the universe we observe is just a sliver, a shadow, a projection of something much larger. It wasn't long before the word multiverse began circulating. A concept once confined to speculative physics papers was now being whispered in conference calls, newsrooms, and encrypted government briefings. Was the signal bleeding in from another universe? Dr. Liang and Dr. Rowe began modeling what kind of structure could emit such a signal. The result was uncanny. It would have to come from a region where dimensional boundaries are thin, where quantum tunneling, dicoherence, and cosmic topology all intersect. In other words, the edge of a universe. If the QLS was peeking in from outside our known four-dimensional space-time, then everything we believe about reality might be incomplete. One of Liang's colleagues, a postdoc named Neha Patel, ran a theoretical simulation using quantum lattice field models. Her program projected the signal structure into a five-dimensional tensor grid, and the waveform began self-repeating, like a message caught in a Mobius loop, a loop with intention. The signal wasn't broadcasting randomly. It was folded, directed, aimed, and it seemed to be reactive. When slightly altered test photons were beamed back toward the source vector, using Earth's most powerful quantum laser arrays, the QLS briefly shifted. Not much, just a fractional delay in wavefront return, but enough to suggest feedback. Someone or something might be listening. The implications were staggering. If this light was a product of higher dimensional interference, then our detectors were witnessing a cosmic event horizon of communication, a boundary, not just of space, but of perception, and still no one could answer the most haunting question: why now? Why had this signal arrived in 2024? Had it always been there, unnoticed? Or was something or someone trying to contact us, now that we were finally ready to hear? As Liang stared at the waveform late one night, she muttered something quietly into her recorder. Either we're the first civilization to detect this, or we're the last one it needed to reach. It's no longer just about astronomy. It's about ontology, about what we are, and where we truly exist. A message can travel across dimensions. Who or what is waiting on the other side? The coordinates pointed to a place that shouldn't matter, a patch of sky astronomers have long overlooked. To most telescopes, it's a blank canvas. But now that emptiness is under a microscope, they called it the void zone, a cold expanse of space just beyond the Perseus Pisces supercluster. It's not just sparse, it's silent. No galaxies, no gas clouds, no radiation, not even dark matter. Or so we thought. In most sky surveys, this region was dismissed as a statistical gap, cosmological noise, a forgotten spot in the vast theater of the universe. But now, it's center stage. The source of the quantum light signal had been triangulated. Right in the middle of this so-called nothing, a place once assumed to be cosmically dead was now producing a pulse of light that bends reality. Dr. Amina Rose stared at the data overlay from the James Webb Space Telescope. Nothing, not even gravitational lensing, the subtle warping of background starlight by invisible mass. And yet, this nowhere was somehow glowing with quantum coherence. To investigate deeper, Dr. Rowe brought in Dr. Hassan El-Karim, a theoretical cosmologist at Princeton, known for his work on exotic topologies and early universe inflation scars. He didn't just see voids as absences. He saw them as potential creases in spacement, and what he proposed changed everything. "We assume a void is empty," he said. "But what if it's folded, not in space, in reality itself?" In physics, certain kinds of voids, known as topological defects, can form in the early moments after the Big Bang. They're like wrinkles frozen into the cosmic fabric as the universe cooled and expanded. These wrinkles might not be visible, but they could interact with light in ways we've never seen. Imagine space-time as a bedsheet, smooth, vast, pulled, taut. Now imagine a twist, a fold, a snag frozen into that sheet for billions of years. What happens when light passes through? That twist, it changes, it remembers. Dr. El-Karim theorized that the QoS may not be a signal emitted from that void, but a signal that passed through it, changed by the defect itself. The void may be acting like a prism, not of color, but of dimensions, and perhaps most chillingly, like a recorder, could the signal we're detecting be a cosmic echo, light warped through a fold in time, reflecting messages, not just from elsewhere, but from elsewhere. Dr. Sophia Liang ran simulations of photonic paths through hypothetical topological defects. The result, the QLs could be the residue of photons caught in a fold, photons that have been looping in space and time for eons, only now escaping through an invisible tear, a tear that, perhaps, just opened. And if that's true, then this signal may have been waiting for us all along, waiting for technology advanced enough to notice, waiting for minds curious enough to decode, or worse, waiting for a cosmic condition that finally aligned. The implications were devastatingly elegant. A wrinkle in spacetime, long dormant, has begun to leak light. Not ordinary light, but structured, entangled, intelligent light. But this led to a disturbing question. Was this fold a natural scar of cosmic birth, or something else? Because if it's artificial, if the fold was placed, or triggered, or engineered, then it might not just be a relic, it might be a door. A portal not in the science fiction sense. No swirling vortex or stargate, but a quantum passage. A bridge where information, not matter, is exchanged across unimaginable gulfs. Some began calling it the folded eye, the place where the universe peeks back at itself, and the more data they gathered, the stranger it became. The QLS pulse exhibited slight variations when observed from different hemispheres. Observatories in the southern hemisphere recorded a fractionally different phase than those in the north, as if the signal was interfering with Earth's position in space. It was acting like a hologram, changing based on the angle of observation, and yet always centered, always anchored to that void. There was no mistaking it now. This wasn't a transmission from a star system. This wasn't a burst from a neutron remnant. This was a phenomenon embedded in space itself. El-Karim's final paper, still unpublished, posed a theory so bold it shook the team. If this fold is indeed distorting quantum light, it may also distort quantum memory. And what we are seeing could be a replay, a broadcast, a message recorded in the folds of spacetime long ago, possibly before our universe reached maturity. And if this signal is a recording, the real question becomes, who made it? And for whom? What if the void isn't the absence of something, but the containment of something we were never meant to find? In the hushed corridors of quantum research labs across the globe, something extraordinary and deeply unsettling began to unfold. It started with a quiet ping at Dr. Sophia Liang's lab in Singapore. A cluster of entangled photons had been behaving erratically during an unrelated quantum communication test. Their energy signatures didn't match the control parameters. When her team isolated the anomaly and traced the timeline, their jaws dropped. The photon behavior had changed. Minutes before the quantum light signal was officially detected. Let that sink in. The signal hadn't just arrived. It had somehow echoed backward in time. Liang immediately contacted Dr. Rowe and the global team. At first, no one believed it. But when 3 other labs, in Germany, Canada, and Japan, reported the same eerie phenomena, the disbelief shifted into quiet panic. The implications were nothing short of mind-breaking. These photons, entangled on Earth, in controlled conditions, appeared to be influenced by a cosmic event that hadn't yet occurred. It defied causality, like hearing thunder before lightning, not just once, but repeatedly. Across the planet, Dr. Rowe sat in stunned silence. What they were observing was retrocausality, effects preceding causes, a deeply controversial concept in quantum mechanics, long dismissed as unprovable fringe theory, and now, here it was, writing itself into the logs of Earth's most advanced quantum labs. But how? Dr. Liang offered a possibility. If the QLS is truly a quantum coherent signal, and if it interacts with space-time folds, then time itself might not be a barrier. It could be refracting through time the same way light refracts through water. Imagine throwing a rock into a still pond, but the ripples move both forward and backward. That's what these entanglement echoes seemed to be. Temporal ripples caused by the arrival of something that breaks linear time. In one particularly alarming case, the National Institute of Standards and Technology in Colorado recorded photon anomalies 12 hours before the global alert on the QLS was issued. Their quantum clock, accurate to within a billionth of a second, had picked up interference patterns with no apparent source. Until now, it's as if the signal was whispering through the quantum substrate of our reality, ahead of itself. This left only one possible conclusion. The signal wasn't just traveling through space. It was interacting with time, and that raised a new, even darker question. If the QLS can affect quantum systems before it arrives, is it trying to tell us something before it happens? Dr. Rowe began feeding time-stamped QLS anomalies into a predictive loop algorithm used by climate scientists to model cascading systems. The results weren't definitive, but they hinted at a coming quantum fluctuation, something large, undefined. What if the signal wasn't just a message, but a precursor? What if it's warning us of an event still on the horizon, a collapse, a collision, a shift? And this is how the cosmos signals a coming storm. And then, something else happened. During a synchronization experiment in Tokyo, researchers deliberately entangled new photons and exposed them to QLS data. The photons responded before the experiment even began. Their spins aligned with a pattern that only made sense after the signal was introduced. One physicist simply muttered, "It's like they already knew." Some began to ask the unthinkable. Is the universe itself participatory? Does the act of observing and expecting create a kind of resonance across time? This theory echoes an old and still hotly debated idea: the delayed choice quantum eraser, a famous experiment suggesting that photons decide how to behave based on whether or not they're observed. Even if that decision is made after they've already traveled. But this was no lab trick. This was playing out on a cosmic scale. If QL's entanglement echoes were real, they could change everything we know about time, causality, and consciousness, because it would mean the future is not fixed, it's influential. It pushes into the past. Some called it impossible. Others quietly asked, what else could the future be reaching back to alter? Governments began to take notice. Encrypted memos between CERN and the US Department of Defense revealed classified efforts to replicate the QLS in controlled time, reversed particle environments. Their goal: understand if the signal could be used to anticipate or even alter major global events. One phrase from a leaked document chilled the scientific community. If we can detect before arrival, can we act before consequence? Suddenly, this wasn't just a discovery, it was a race. Dr. Rowe, meanwhile, remained focused on the signal's behavior. She noted something strange. The QLS entanglement patterns only appeared when human observers were present. When recorded remotely, with no human eyes watching, the signal's coherence dropped. This echoed something deeply uncomfortable. Was it responding to consciousness? What if observation isn't just passive, but participatory? What if this signal isn't just being seen, but is seeing us back? At the edge of reality, a message echoes through time, not ahead, not behind, but all at once. A whisper in the dark, saying, I was always here. You just weren't ready to notice. The breakthrough came not from a telescope, but from a pattern, somewhere deep in the data centers of the European Astrophysics Archive. An artificial intelligence trained on signal pattern recognition began drawing strange correlations. At first, the software flagged it as a false positive, an anomalous burst of noise, but then it repeated, not the signal itself, but its structure in the quantum light signal's waveform. Buried beneath the entropy were precise intervals, harmonics that shouldn't be there, Fibonacci ratios, prime number spacings, golden angle diffraction arcs. It wasn't just random light, it was organized. For Dr. Amina Rowe, this moment shifted everything. She brought the data to Dr. Liang, who immediately overlaid the patterns using an advanced spectrographic mapper. The results sent a shiver through the room. The light was forming recursive geometries, spiraling waveforms that echoed sacred mathematical constants found in nature, the same patterns seen in sunflower seeds, seashells, and galaxies. But these spirals weren't biological. They were intentional. This isn't just noise, Liang said. It's a language, a quantum dialect written in light. The phrase stuck, the language of light, and suddenly the QLS wasn't just a phenomenon. It was speaking, but what was it trying to say? The team turned to machine learning specialists, engineers trained in decoding alien-like signals, often used in CTI simulations. They fed the QLS waveform into models designed to parse communication, attempts from non-human intelligence. What emerged was uncanny. Not words, not symbols, but logic. The QLS contained layered structures, self-repeating, nested frequency bands that mirrored ancient logic gates, the kind used in computers, except made from photons. Not electricity, the light was behaving like a processor, a message that computes as you receive it. It wasn't broadcasting static data, it was interactive, a kind of quantum handshake, a greeting that reveals meaning based on how you choose to engage. Think of it like this. Imagine receiving a book that only reveals its contents based on the emotion you feel while reading it. Each interpretation, each measurement, each observation changes what you learn. The implications, terrifying and beautiful, because it meant the signal wasn't just intelligent, it was responsive. This pushed Rowe and Liang into dangerous territory, the realm of conscious communication. Could this signal be designed not for machines, but for minds? They consulted neuroscientist Dr. Elijah Patel, known for his work in cognitive encoding through photonic stimulation. His lab had been testing how light frequencies can influence brainwave patterns, how flashing harmonics could induce trance states, even hallucinations. When Patel was shown the QLS waveform, he paused, then said, This isn't a code, it's a conversation starter." He proposed a radical idea. What if the QLs was designed to sync with conscious awareness, to initiate thought, not transfer data, a frequency that doesn't inform you, but causes you to realize something, a mirror for minds? If so, the QLS wasn't just a signal, it was a psychotechnical artifact, a light-based interface, designed to resonate with the observer's consciousness. That's when things got stranger. A small team of test participants, exposed to the signal's harmonics through visual pattern playback, reported vivid, dreamlike sensations. Some described feeling like they were inside a star. Others said they experienced geometric tunnels of impossible light. One participant, a linguist named Clara Yu, emerged in tears. "It didn't say anything to me," she whispered. "It just understood me." Was this anecdotal or something deeper? Dr. Liang wasn't sure, but she ran the QLS through an fMRI-linked light processor, pulsing its harmonics into brainwave analysis models. The results showed subtle neural entrainment. Human brains weren't just observing the signal, they were entraining to it. In effect, the signal was tuning our minds like instruments. And this raised the question no one wanted to ask: what happens when a mind and the message fully align? Could it trigger knowledge, awakening, collapse? More researchers joined: philosophers, linguists, signal theorists. One proposed that the QLS wasn't from an alien species or another universe, but from consciousness itself, that the universe, through some forgotten law, had found a way to speak a lingua cosmica, a language not spoken, but felt, and the way we perceive it, through machines, through observation, through meaning, becomes the very syntax of that language. If that's true, then light isn't just how we see the universe, it's how the universe sees us. But we're still at the beginning, still deciphering the first syllables of a sentence older than stars. So, now we ask you, watching this, if the universe was trying to communicate, would you know how to listen? Would you understand that the message might not arrive as words, but as a feeling of being watched by the stars? The room was quiet, save for the soft hum of processors. Quantum cryptographer Miguel Santero leaned over his desk, eyes bloodshot from 16 hours of continuous decoding. He wasn't part of the original discovery team. He wasn't even an astronomer. He was a former intelligence contractor, someone who had spent most of his adult life untangling impossible codes. some of which were never meant to be solved. But this one was different. It didn't feel like a cipher. It felt intentional. Santaro had volunteered after seeing a cleaned version of the QLS waveform, POSTED, anonymously on a fringe physics forum. Within minutes, he noticed something strange. The signal's phase intervals were not evenly distributed. They followed a deliberate irregularity, like musical syncopation. That asymmetry, seemingly chaotic, was actually the key. He ran the waveform through a modified 5-dimensional Hilbert transform, a tool normally used for high-dimensional signal analysis in quantum radar systems. The result was unexpected. Not noise, not language, but shape. The QLs contained a spatial pattern, a complex, multi-layered map. When reconstructed as a gravity field using tensor modeling, it revealed an impossible structure, a 5D representation of gravitational topology that couldn't exist in our universe. And yet, there it was. Dr. Rowe, upon seeing the reconstruction, froze. It wasn't abstract. It looked like a star chart. But none of the points matched known constellations or local galactic formations. Santaro cross-checked the spatial anchors against every stellar catalogue available. Nothing matched, not in our region, not in our supercluster, not even across simulated exoplanet models. Wherever this map pointed, it wasn't here. That's when Dr. Hassan El-Karim made a bold suggestion. What if this isn't a map from somewhere else? What if it's a map to somewhere else? His proposal, the QLS, may originate from, or pass through, a region of space that isn't bound by 3-dimensional constraints. A brain, a multi-dimensional sheet predicted by string theory. A parallel universe, a hidden layer of the cosmos stacked beside our own. This idea, long dismissed as speculative math, now had a traceable structure. If true, the map was showing us how to reach it. But that raised an even more disturbing possibility. What if it's not a roadmap for us? El-Karim asked, but for them. A cosmic address, a transdimensional invitation, or a breadcrumb trail not to guide us, but to guide something else here. Santaro refined the reconstruction and found a second, fainter layer, a nested geometry overlaid with a harmonic shift. This layer wasn't spatial, it was temporal. The QLS, it seemed, didn't just contain a location, it contained a when. This was a spacetime map, but to what? A possibility began forming that no one wanted to voice. Could the QLS be a warning? A record of something that happened, or will happen, at that spacetime coordinate? Rowe fed the data into deep learning quantum simulations, searching for energetic profiles. One pattern emerged again and again, a localized gravity spike, followed by an entropic collapse. To put it bluntly, a cosmic implosion. The AI interpreted it as a quantum-level event, possibly the birth of a micro-black hole, or worse, a rupture, a break between dimensional membranes. But the strangest part, that event hadn't happened yet. The model placed the collapse less than 150 years into our future, in the year 2187, near our solar system, for Rowe and the team. It was a tipping point. The QLS wasn't just a signal, it was a timeline, a record of space-time ruptures, encoded as a map, wrapped in entangled light, whispering across the void. It might be ancient, or it might be from the future, but either way, it was pointing to an event we're not ready for. The philosophical implications were staggering. If this was a message from another universe, it meant we are not alone in the multiversal dark. If this was from our future, it meant time is not a line, but a loop. And if it was from something else entirely, then we are being observed, not through telescopes, but through dimensions. And maybe, just maybe, we were never supposed to find this. But now that we have, the question isn't whether we understand the message, it's whether we've already become part of it. So, consider this. If the first intelligible message from the cosmos is a map to our own destruction, do we follow it? Or do we try to change what's already written in the light? It was the archivists who made the discovery, not the astronomers, not the physicists, but the data miners, the forgotten foot soldiers of science who sift through old observations few ever read again. Deep within the petabyte vault at the Global Astrophysics Archive in Geneva, a research assistant named Leo Barter was running spectral comparisons across historical sky scans. He wasn't looking for anomalies. He was looking for calibration drifts, the sort of minute errors that creep into long-term instrument records. But then he found something, out of place. A waveform, buried in observational noise from 1983. At first glance, it looked like static. But when Leo ran it through a modern filter algorithm, the kind powered by machine learning no one had back then, the signal sharpened. It wasn't just similar to the QLS. It was identical. The signal had already arrived. 40 years ago, Leo cross-checked with dozens of archives. And then, like scattered breadcrumbs, more fragments appeared. 1991, 1999, 2007, each time faint and fragmented, each time dismissed as irrelevant noise. The signal had been whispering to us for decades. We just weren't listening with the right ears. Dr. Rowe was stunned. It wasn't new. It was old, persistent, patient, and suddenly a new theory emerged. What if the quantum light signal had always been there, hiding in the background hum of space? What if our instruments were never sensitive enough to hear it until now? It wasn't that the signal had finally arrived. It was that we had finally evolved to detect it. This revelation sent shockwaves through the community. If the QLs had been echoing through the void for decades, or even longer, why had it only now become coherent? What had changed in the universe? What had changed in us? Dr. El-Karim proposed a haunting possibility. Perhaps it's not the signal that's new, but the window through which it escapes. He referred to a hypothesis few dared to entertain, that the fabric of space-time itself might be thinning. As the universe expands, stretching like a balloon inflated beyond, design quantum boundaries might weaken. The vacuum energy, the dark energy that drives expansion, could be pulling open quantum windows, and through those windows the signal seeps in. In this model, the QLS wasn't actively reaching us. It was simply bleeding through, a resonance from another layer of existence, now leaking into ours. But that raised a disturbing idea. What if other signals, other things, could come through as well? Dr. Liang noted that the 1983 signature was weaker and more chaotic. By 2007, it had become more structured, and in 2024, it reached clarity. The signal wasn't just repeating, it was evolving. Was it learning, adapting, or was something on the other side getting closer? Meanwhile, archival analysis revealed something even stranger. In 1991, when the QLS was barely a whisper, a solar observatory in orbit had detected an unexplained fluctuation in neutrino emissions from the Sun. Just milliseconds after the signal peaked, the odds of a coincidence were astronomically small. Could the signal affect our star? Could it affect us? Biological labs, curious about quantum light's interaction with DNA, began searching health records from regions near observatories. In 2 cases, researchers found inexplicable neurological spikes in individuals living within range of sensitive QLS detection zones, vivid dreams, hallucinations, sudden bursts of mathematical insight, all within days of past signal appearances. It sounded like fiction, but what if the signal wasn't just data? What if it was interaction, an influence, subtle, sub-perceptual, preparing us slowly, over decades, for something we couldn't yet understand? Dr. Rowe sat in her office long past midnight, staring at a printout of the earliest fragment. From 1983, it was messy, fragmented, raw, like the first breath of something ancient, trying to speak, and for a moment she whispered aloud, "What if this has always been part of us?" The silence before the signal wasn't emptiness, it was ignorance. Our instruments were blind, our minds were closed. But the light, the impossible, quantum light, had always been reaching out, waiting, and now, with each new discovery, we peel back one more layer of our arrogance, one more veil of false certainty. The universe was never quiet, we were never alone, we just didn't know how to hear. So we must ask if this signal has always been there, encoded in the background, shaping the edge of awareness. Then how much of what we call reality has already been touched by it? By now, the quantum light signal had shaken every corner of the scientific world. But just as theories about cosmic civilizations and dimensional folds reached fever pitch, a new and unsettling hypothesis began to spread, one that felt almost too strange, too recursive to contemplate. What if the signal isn't from out there at all? What if it's from us, but not the us of now? It began with Dr. Lian Ko, a quantum theorist in Seoul, running the QLS waveform through a new time loop predictive model. She had built the model to test if quantum information could ever encode echoes from its own future. A puzzle so convoluted it bordered on philosophical paradox. But the results stunned her. Her simulations showed the signals. Characteristics could, under certain circumstances, be generated by advanced quantum communication experiments, the kind we might conduct. In the future, she brought her findings to Dr. Rowe and Dr. Liang, who at first dismissed the idea as mathematical coincidence. But the deeper they looked, the more plausible it seemed. The QLs could be a temporal echo, a reverberation of technology we have not yet invented, but someday will. If this was true, it would mean we were not just observers in the universe, but participants in a closed causal loop, our own future discoveries reaching back to guide or warn our present. That chilling possibility opened up a new avenue of research. The team isolated a fragment of the QLS and subjected it to advanced temporal deconvolution, a process designed to tease out hidden timelines within quantum data. What they found was even stranger, a subtle subpattern, emerging only when the signal was processed using time-symmetric algorithms. This subpattern, when decoded, pointed to a specific set of astronomical coordinates and a date, Earth's orbit, year 2143. That date didn't correspond to any known future event, at least not yet. But in predictive models, it aligned with a potential gamma-ray burst scenario, a catastrophic event capable of sterilizing entire planets. There was no evidence such a burst was imminent. No known progenitor stars in our region, no precursor supernova, no threat at all. Yet, the signal seemed to reference it, as if it was warning us of a disaster still to come. Was this an accident? A side effect of future human experiments? sending quantum information through spacetime and, in doing so, casting ripples backward? Or was it intentional? If future scientists had found a way to manipulate quantum light to send messages into the past, what would they want us to know, to avoid? Or were they simply trying to tell us that time is a far stranger river than we ever imagined, one in which cause and effect can swirl and double back, forming loops of possibility? Dr. Liang speculated on camera. We're so used to thinking of the past as gone and the future as unknown. But what if they're braided together like strands of quantum light? What if the universe allows for memory in both directions? It was a dizzying thought. A universe not just old and cold, but aware, storing echoes of what is yet to come. The implications weren't just theoretical, they were deeply personal. For every scientist on the project, the possibility that the signal was a product of human hands just not yet changed their relationship to the work. It meant they might one day become the authors of the very mystery they now sought to solve. For Dr. Rowe, the question took on existential weight. If we're receiving messages from our own future, does that mean we can change what's coming? Or are we only learning to accept it? And for viewers, for you, the question becomes, what would you say to your past self? If you could send a single, impossible signal through time, would you warn? Would you encourage? Or would you simply watch, hoping your message is understood? The QLs remains as enigmatic as ever, alien, yet maybe familiar, cosmic, yet possibly human. If the signal is us, from a future not yet written, then every discovery brings us closer to a new kind of self-awareness. A cosmic mirror reflecting not just our place in space, but in time itself. So what if the message isn't a warning, but an invitation? To remember that the universe is never finished with us, and that maybe neither are we. There are moments in the history of science when the rules bend, when the map of reality itself must be redrawn. The quantum light signal, QLS, had become just such a moment. With each discovery, the boundaries of physics blurred, and what was once theoretical fantasy began bleeding into concrete data. In closed-door conferences and encrypted video calls, the world's top physicists struggled to articulate a simple truth. We were witnessing the birth of a new kind of physics, one forbidden by the laws we thought unbreakable. It started when Dr. Sophia Liang's team, probing deeper into the QLS structure, discovered quantum gravity effects woven into the light itself. Usually, gravity and quantum mechanics are kept apart, one ruling the large, the other the tiny. But in this signal, the separation failed. The photons didn't just carry energy, they seemed to carry memory, as if each particle had witnessed something ancient and brought that knowledge to us encoded in its quantum state. These weren't just massless messengers. They were messengers with history. Dr. Rowe called it the massless particle with memory. She was not alone in this realization. Around the world, research groups noticed the same anomaly. Quantum decoherence times far longer than theory allows, as if the signal was shielded by some new principle, or perhaps by intention. It wasn't long before governments took notice. A flurry of classified memos and international pings began to crisscross the planet. DARPA, CERN, and the China National Space Science Center all launched special interest groups. Funding flowed overnight. Teams were given carte blanche to replicate the QLs in controlled environments. What was at stake? If the QLS was not just a phenomenon but a technology, it could be the most advanced artifact in history, one that might unravel secrets of energy, communication, even time itself. But there was a problem. attempts to recreate the signal in the lab failed. No matter the energy, configuration, or material, nothing produced the same entanglement or phase coherence as the real QLS. It was as if the signal required something we didn't possess, or didn't yet understand. That didn't stop the theorists. Dr. Hassan El-Karim proposed that the QLS existed in a domain where quantum information and gravitational curvature are entangled, a region outside the known standard model, where even the laws of conservation might be suspended. If true, this would be the first evidence that quantum gravity, the holy grail uniting Einstein and Bohr, could be manipulated in the wild. But what if this was only the beginning? Within weeks, whispers of quantum weapons began surfacing. On dark science forums, would a signal like this allow for instant, secure communication across galaxies, or, more ominously, across time? Could it be used to manipulate probability itself? Was it a tool for peace, or for control? Dr. Liang resisted the paranoia. She argued that the QLS was not a weapon, but a revelation, a kind of Rosetta Stone for reality, revealing the hidden architecture beneath our universe. She invited philosophers to join the debate, hoping a wider perspective might prevent a scientific arms race. But the curiosity only grew. One researcher from CERN, Dr. Jürgen Steele, published a preprint claiming that fragments of the QLS could be interpreted as instructions, recipes for manipulating quantum fields in previously unimagined ways. His claims were unproven, but they electrified the community. The idea that the signal might not just be data, but blueprints, forced every physicist to reconsider their ethical boundaries. For Dr. Rowe and her team, the mood turned somber. What if, in seeking the signal's secrets, humanity was prying open a door we weren't ready to walk through? What if the QLS was a test, a puzzle meant to reveal which civilizations are wise enough to handle the knowledge, and which are doomed by their own ambition? As days turned to weeks, the world outside remained oblivious to the stakes. But inside the labs, something had shifted. Every discovery was a thrill and a warning, because this was no longer science as usual. This was forbidden physics. The QLS had shown us a reality stranger than fiction and the power to change it. So the question is no longer, can we understand it? It's, should we? And if knowledge is power, what kind of future do we invite by looking deeper into the lights? What would you do if you stood at the edge of understanding, staring into a signal that might reshape everything we know and everything we could become? It was Dr. Luca Mendez who, during a late-night Zoom session, uttered the phrase that would unsettle the entire team. What if we're not the first to look? What if we're not even alone in this conversation? The Watcher's hypothesis had hovered on the edge of speculative science for decades, a whispered suggestion that somewhere, out there, other intelligences might not just be listening, but actively observing. Yet, the quantum light signal was pushing this hypothesis from myth into the realm of unsettling possibility. To understand, the team revisited the QLS's unique behavior. Unlike any known cosmic beacon, its signature wasn't merely persistent. It was reactive. Minor tweaks in observation, changing the angle of detection, the timing, the quantum state of receivers, would trigger subtle phase shifts within the signal itself. It was almost as if the QLS was aware it was being watched. This wasn't supposed to happen. In science, an observation is a passive act. But now, the very act of seeing was changing the scene. Dr. Rowe recounted an experiment at the Alma Observatory, where synchronized telescopic arrays across 3 continents coordinated to observe the QLS simultaneously. The result was a synchronized phase jump, followed by an oscillating echo that stabilized only after the observers stopped watching. It's as if, Rowe whispered, the signal didn't just expect to be seen. It required it. That possibility sent shivers through every researcher on the call. If the QLS was dependent on being observed, if it was waiting, even hungering, for consciousness, then perhaps the signal was not a simple broadcast, but an invitation. The concept resonated with an old, controversial idea from SETI, the lighthouse or beacon theory. Advanced civilizations might send signals not to declare their presence, but to probe for intelligence capable of noticing and responding. But the QLS took it further, because this lighthouse seemed to shine a light back. Mendez hypothesized that the QLS could be a quantum version of the Fermi paradox's zoo hypothesis, in which advanced beings observe less advanced species from afar, intervening only when the time is right, or when their attention is detected, if true. The message was clear. We have noticed you noticing us. As word spread, other teams began to test the QLS's reactivity. In Shanghai, researchers ran automated observations, only to find the signal grew faint. When live human attention was focused on the data in real time, the signal pulsed brighter, as if answering a gaze. This effect was dubbed the watcher's mirror. It was as if consciousness, human or otherwise, was the last piece needed to complete the circuit, not just a receiver, but a participant. What could that mean for the story of intelligence in the universe? Were we being watched by cosmic ancestors, alien minds, or even something more abstract, a self-aware universe folding itself in light? The stakes had never felt higher. Some scientists began to grow uneasy, even afraid. If we had become the observed, could there be consequences? Would revealing ourselves invite curiosity or intervention? Dr. Liang, always the skeptic, posed a haunting counterpoint. We might think we're on the verge of discovering others, but what if we are simply awakening to a truth that's always been here? What if the universe's silence was not absence, but patience, a silence waiting to be broken by the first civilization, willing and able to look back? The team found themselves in a new kind of uncertainty, one not just of data, but of identity. Had we opened a cosmic channel, or simply found ourselves reflected in a mirror far older and deeper than we can imagine? With every new observation, the QLS felt more like a conversation, one whose rules we do not yet know, and whose answers we may not be ready to hear. So, we ask you, if you knew the universe was watching and waiting for your gaze, would you dare to look deeper, or would you turn away from the watcher in the light? Until now, the quantum light signal had been a cosmic puzzle, data, waveforms, mathematics. But one experiment brought its mystery uncomfortably close to home. Dr. Sophia Liang's laboratory, in collaboration with Dr. Elijah Patel's neuroscience team, began a series of controlled studies. The question, could the QLs interact directly with biological matter? The idea was bold, maybe even reckless, but the moment called for it. They decided to expose carefully prepared human tissue samples to QLS harmonic light, a recreation of the signal's unique frequency patterns. No one expected what happened next. The samples weren't damaged, not in the way high-energy light can fry DNA or shred proteins. Instead, something remarkable occurred. The proteins in the tissue began to fold differently, not randomly, but with precise, repeatable patterns, as if the light carried instructions, guiding molecules into new shapes. It was as if the Q was more than a message. It was a blueprint, Dr. Patel's team dubbed this phenomenon photonic induction, a process where quantum-tuned light seems to imprint information onto living matter, not through brute force, but by subtle quantum resonance. As word spread, teams around the world attempted to replicate the results. In labs from Zurich to San Francisco, similar effects were observed. Muscle cells developed microstructures never before documented. Neural tissue showed brief surges in synaptic connectivity, followed by a return to baseline, but always with a curious after effect, an increase in signal clarity when exposed to the QLS again. As if the tissue had learned something from the encounter. This sparked a radical question. Was the QLS a mechanism for transmitting life itself? Could it be how the universe seeds biology, sending not just energy, but actual patterns for complexity encoded in quantum light? The idea sounded more like ancient myth than modern science, panspermia by photonic blueprint. But the evidence grew, and so did the unease. Philosophers and theologians began to weigh in. Was this how consciousness first emerged, not by random chemical chance, but through a kind of cosmic induction? Was the QLSA universal signature, a code for life, written not in DNA, but in light? In one experiment, a researcher named Clara Yu, who had previously experienced dreamlike states while observing the QLS, volunteered for a non-invasive neural stimulation trial. She sat before a QLS patterned light array, electrodes mapping her brainwaves. As the light pulsed, her alpha and gamma rhythms shifted. She reported a sudden, overwhelming feeling of connection, as if her mind was resonating with the cosmos. Yu's post-experiment, EEG, revealed an unusual coherence. Pattern, never before recorded. Was this proof of something beyond, or simply the brain's way of interpreting an extraordinary stimulus? As debate raged, another question surfaced. Could this effect be harnessed? Was there a risk or a promise in tuning human biology to a cosmic signal we barely understood? For Dr. Rowe, the answer was both thrilling and terrifying. If the QLS could shape matter and mind, then its purpose might be far greater than a simple transmission. It could be a method for initiating transformation, not just of life, but of consciousness itself, a bridge, a nudge, an awakening, or perhaps an invitation to evolve. In ancient myths, light is the symbol of knowledge, of creation, of divinity. Now, science found itself confronting a literal truth, a signal from the edge of the cosmos, capable of writing patterns into the flesh. If the QLS was such a tool, who or what first used it, and to what end? Was this a universal process, scattered throughout the galaxies? Or were we witnessing a singular event, a message meant just for us, at this moment in our evolutionary journey? Dr. Liang's final question to her team captured the tension perfectly. We know the light can encode life, but can it also encode destiny? As we stare into the quantum unknown, one thing is certain. When the cosmos writes its message in light, sometimes it writes it in us. Would you accept that message, or turn away from the patterns forming in your own flesh? The greatest discoveries in science often come from boldness, from refusing to accept the limits drawn by our own expectations. And so it was in Switzerland, at the ultra-secure quantum interference laboratory outside Geneva, that Dr. Amy Rowe and her international team decided to take the riskiest step yet. For weeks, they had decoded, analyzed, and debated the quantum light signal, but always as passive observers, never as participants. What if, Rowe asked, the universe was waiting for us to answer? The team proposed an audacious experiment, not just to observe the QLS, but to respond. They set to work building a replica, a laser system tuned to mimic the QLS's harmonic structure, phase, and entanglement profile. It took days of calibrating quantum emitters, adjusting optical lattice, and programming feedback algorithms capable of detecting minute shifts in photon states. The lab was a fortress of silence, soundproofed walls, Faraday cages, secure data streams. Every movement was logged, every hypothesis double-checked. Even so, a sense of nervous anticipation filled the air. No one could predict what would happen. The night before the attempt, Dr. Rowe found herself alone in the control room, gazing at the endless swirl of simulation data. What if this was the moment humanity truly joined the cosmic conversation? At precisely 2:03 a.m., the countdown began. The quantum emitters powered up, sending a stream of entangled photons into the void, carefully targeted toward the coordinates of the original QLS. The team held their breath as the data began to stream in. For 72 hours, nothing happened. No echo. No spike in readings. Just the normal background noise of the universe. Disappointment mingled with exhaustion. Some on the team began to question the wisdom of the attempt. Had they misunderstood the signal? Was it never meant to be answered? Then, on the third day, the monitors flickered. At first, it was a glitch, or so it seemed. But as the team cross-checked the incoming data, their skepticism turned to awe. A new signal had arrived, shorter, sharper, more focused than the original. QLS, the pattern was unmistakably artificial, yet different, as if responding to their own transmission, but adding something new. The waveform mirrored their own in structure, then abruptly shifted, introducing harmonic variations that none of their models predicted. It was a reply. The lab fell silent. A collective sense of disbelief mingling with rising dread. Every scientist, there felt it a chill that ran deeper than the sterile, refrigerated air. Dr. Rowe watched as the reply's waveform stabilized, locking onto a resonance the original QLS had only hinted at. She whispered, almost to herself, "It knows." What it was, no one could say. But the signal, whatever its source, was now part of a true dialogue. Dr. Sophia Liang ran quantum phase analyzers on the new reply. The photons contained embedded structures with even higher dimensional folding patterns. Her AI models could only describe as intentional variability. Not a simple bounce back, but new information. As if the responder was demonstrating an understanding of their message, then extending it. A two-way exchange, a handshake across the unknown. The implications reverberated around the world. Was this the first interuniversal communication? A proof that the cosmos could not only listen, but speak if you dared to ask the right question. Security protocols locked down the lab. Governments demanded updates. Some whispered of existential risk, the possibility that humanity had just pinged a reality it should have left undisturbed. For the scientific team, wonder was mixed with humility. Their experiment had changed everything. They were no longer passive recipients of a message. They were now active agents in a conversation whose rules and risks they could not yet imagine. The philosophical ramifications were staggering. What if, by breaking the barrier, they had invited something through? What if every question, every experiment, was itself an act of creation, weaving new threads into the fabric of possibility? Dr. Rowe addressed her exhausted, exhilarated team. For the first time in history, we've sent a question out into the dark, and something has answered. It's no longer about understanding the universe. It's about becoming part of it. And, as they stared at the glowing, shifting pattern of the reply, every scientist present understood a single truth. Nothing would ever be the same again. So, if you had the chance to ask the universe one question, knowing it might answer, what would you say? What would you risk to break the barrier? As the new reply signal pulsed through the world's most sensitive instruments, it brought with it a shiver of the unknown. For the first time, the quantum light signature was no longer just a mystery to be solved. It was a presence, an intelligence, that had turned its gaze in our direction. And then, something even stranger happened. A ripple appeared in the cosmic microwave background near the very coordinates where the original QLS had first emerged. It was a faint anomaly, a deviation, so subtle it was nearly lost in the static of the universe's birth cry. But as data from radio observatories and space telescopes poured in, it became clear something had shifted at the edge of the void zone. Physicists struggled to explain it. Was this just the result of a rare fluctuation, a statistical mirage, in the noise of deep space? Or was it a consequence of our reply, a sign that our message had not only been received, but had somehow touched the fabric of the cosmos? Dr. Hassan El-Karim, watching the data unfold, felt a mounting dread mixed with wonder. The ripple was spreading, causing slight distortions in the local spacetime grid. Gravity wave detectors picked up an unfamiliar signature, a kind of quantum thrum reverberating through the fold, like the faint vibration of a distant drum. The QLS itself grew chaotic, its phase flickering in and out of coherence. Patterns dissolved into apparent randomness, then reassembled into a new rhythm. It was almost biological, like the heartbeat of some unseen entity waking from ancient slumber. Dr. Sophia Liang's models suggested that the fold at the signal's origin was more than a simple defect or wrinkle in spacetime. It was behaving like a container, a pocket dimension where the rules of matter, energy, and even consciousness might be fundamentally different. The speculation was electrifying and terrifying. What if we've disturbed a kind of intelligence that doesn't exist inside time as we understand it? Liang wondered aloud. A being or a system that perceives the universe as a whole, not as a chain of events, but as a single living pattern. She and Dr. El-Karim posited that the fold might be home to an information-based life form, a consciousness encoded not in molecules, but in quantum states, a mind woven from the foam of possibility at the universe's edge. If so, then our reply had not just been heard, it had become part of that mind's internal dialogue. The QLS's new rhythm, its strange coherence, might be an attempt to integrate our message into its own pattern of being. But what would such a consciousness want? Would it even perceive us as life, or as a fleeting anomaly, a blip of order in the vast sea of entropy? The more they studied the QLs, the more it felt less like a beacon and more like a threshold. Crossing it meant entering a new relationship with the unknown, one that might transform us in ways we can't predict. Meanwhile, gravitational lensing images from the Hubble ultra-deep field showed faint, shifting shadows in the void zone, structures that seemed to appear, dissolve, and reappear in a cycle matching the new QLS rhythm. Some theorized these were manifestations of higher dimensional objects, glimpses of life flickering across the boundary between worlds. For Dr. Rowe, the question became almost spiritual. If something truly lives in the fold, then we are now connected, not by biology, but by information. We've become part of a greater story, one that stretches beyond the limits of flesh and time. Yet even as the excitement grew, so did the anxiety. What if our signal had not awoken a friend, but something far less benign? What if we had become a question in a mind vaster than worlds, a curiosity to be tested or ignored? As the QLs stabilized into its new, almost organic rhythm, the team realized they were facing a boundary not just of science, but of meaning. A doorway into the unknown, trembling on the threshold of the possible dot. So now the question echoes for all of us. If you could speak to whatever lives in the fold, what would you hope to learn, and what would you fear to awaken? For weeks, the new rhythm of the quantum light signal pulsed steadily, hypnotically, through the instruments of the world's finest observatories. As scientists worked around the clock to decode its patterns, a realization dawned. This signal was not just new. It was ancient. Dr. Sophia Liang, sleepless and driven, dove deeper into the structure of the QLS. Using the latest quantum computer arrays, she mapped its harmonics at the most granular scale yet attempted. The result was nothing short of chilling. Buried within the interference patterns were echoes and imprint, a fingerprint equal to the Planck epoch. The Planck epoch, the first sliver of a second after the Big Bang, a state of the universe so hot and dense that matter, energy, and the laws of physics as we know them had not yet separated. To Liang, this was both exhilarating and terrifying. We're looking at a signal whose foundation was forged at the birth of time, she whispered. What did it mean? Had the QLS carried this signature for eons, encoded in the fabric of spacetime itself? Or was this the origin of the signal born with the universe, echoing ever since, growing clearer only as consciousness evolved enough to hear it? The team fed the signal through cosmological simulation engines, tracing its properties as they would have behaved in the early universe. Every test pointed to the same unsettling truth. The quantum fingerprint matched theoretical models of information. Density at the beginning of all things. It was as if the QLs was not just coming from the edge of space, but the origin of time. The philosophical implications threatened to overwhelm. Was this the universe communicating with itself, preserving a message through the ages, waiting for some distant descendant to recognize it? Was the QLs the voice of the cosmos recorded at the moment of awakening, transmitted across eternity, awaiting the birth of listeners able to comprehend its depth? Dr. Rowe posed the question that had begun to haunt every member of the project. What if the signal isn't just out there? What if it's in everything encoded, in the matter that makes us, in the light that lets us see? The team found further evidence in the faintest fluctuations of the cosmic microwave background. The QLS was woven into the same frequencies as the universe's oldest light and afterglow, a lingering resonance from the beginning. If you could see reality as pure quantum information, you'd see the QLs everywhere, in every atom, every photon, every breath. For Dr. El-Karim, this insight was humbling. It meant the signal was not just a message, not just a map or warning. It was a kind of cosmic memory, an echo of creation, alive and whispering in the dark. But there was another, deeper layer. As the quantum models were pushed further, they revealed that the QLS's harmonics were self-similar fractals, repeating across scales, from the subatomic to the galactic. The same rhythms, the same mathematical curves, over and over, as if the universe itself were built upon this signature. If that's true, then the QLS is not a separate phenomenon. It is the foundation, the voiceprint of existence. The question shifts. Were we meant to find this? Or is our discovery inevitably consequence of being part of the same cosmic story. For viewers, imagine, for a moment, that every moment of wonder you've ever felt, every spark of curiosity, is an echo of that first cosmic song, carried forward by light through space and time. If you could hear the true music of the universe, would you recognize it? Would it change how you see yourself? Or would you realize you've been part of the melody all along? As the team stared into the data, exhausted and changed, Dr. Rowe wrote a final note in her journal. If this is the echo of the origin, then we are all its children, and the universe remembers us, even if we forget ourselves. At the edge of time and space, the QL's whispers a truth older than memory, that all things are connected and all stories are one. And then, as suddenly as it had arrived, the quantum light signal faded. No cosmic explosion, no grand finale. One moment, the world's observatories were flooded with its intricate harmonics, their sensors alive with possibility. The next, a hush fell over the data streams. The signature vanished, like breath on glass. At first, scientists thought it was a glitch, a failure in the network. But as hours stretched into days and the silence persisted, reality settled in. The signal was gone. The instruments that had once sung with impossible information now recorded only the familiar whisper of cosmic background noise. The disappearance triggered a wave of reflection and, for some, quiet grief. After months of living with the cosmic mystery, the team felt its absence like the end of a dream. Had they missed their chance to understand? Had they asked the wrong questions? Or was the universe always meant to speak only in riddles, leaving us suspended between awe and uncertainty? But then, amid the stillness, something subtle yet extraordinary emerged. A faint residual pattern remained, woven into the final echoes of the data, a sequence of harmonics that matched nothing ever catalogued from space. The team called it the last frequency. It didn't fit the mold of any known cosmic process, nor did it resemble any artifact of the previous signal. But when Dr. Sophia Liang overlaid it with terrestrial data, she froze. The harmonics matched with uncanny precision. The Schumann resonance, Earth's natural electromagnetic heartbeat, the gentle pulse formed by lightning storms echoing between ground and sky. This couldn't be a coincidence. It was as if the universe, in its parting gesture, had synchronized its voice with our planet's own rhythm. The QLS, once a visitor from the edge of time, had left behind a whisper, in tune with the very ground beneath our feet. The realization rippled through the team. For Dr. Rowe, it felt like a blessing and a burden, a sign that the cosmos had not simply withdrawn, but left a piece of itself within our reach. Maybe the message was never meant to be deciphered, but to be felt, lived, carried within us. Dr. El-Karim likened it to an encounter with the sacred. It's as if the universe touched us and then withdrew, leaving a fingerprint on the world itself. We are changed, even if we cannot say how. In the weeks that followed, researchers worldwide scoured the data, hoping for the QLS's return. Some built elaborate detectors, waiting for the faintest echo. Others turned to philosophy, poetry, or music, trying to make sense of what they'd experienced. And all the while, the Schumann resonance hummed steadily, a gentle, almost imperceptible reminder that something extraordinary had passed through our lives. For many, the question remained, was it a farewell or a fusion? Had the universe merged a part of itself with our world, or simply shown us what was always there, hidden in plain sight? In the end, there was no answer, only the memory of the light and the questions it left behind. What if, in noticing the signal, we became something new? What if, by daring to listen, we invited the universe to notice us? The closing days of the project were marked by silence and gratitude. Dr. Rowe, walking beneath a midnight sky, looked up at the stars with new humility. For all our knowledge, all our technology, all our hunger to understand, we are still children at the edge of the unknown, listening, hoping, dreaming, and perhaps that is enough. As you finish this journey, ask yourself, if the universe called your name in light, would you recognize the song? Would you answer or let it fade into silence? What stories might still await in the darkness, waiting for the courage of a single, listening heart? The quantum light signal is gone, but somewhere in the frequencies of the earth, and the memory of all who listened, its echo endures. What do you think the signal was? A message from the stars, or from ourselves? Could quantum light be the next frontier of contact, or consciousness itself? Comment your theory below. Subscribe if you believe the universe still has stories it's dying to tell, because one day that signal might return, and next time it may call your name.